all the properties of light, what we study, all that you can apply for EM wave also. So they may test you with respect to EM wave, all that particular thing. Even the interference, I'm telling, standing wave. So we may get, if there's a conducting medium, so can we get any standing waves as standing wave corresponding to an EM wave can be obtained. And the conducting medium should be a node. So all the things. So when I say similar to wave means all the similar to what we discussed standing wave, the EM wave, the superposition of two EM waves. So one, this is the incident wave, this is a reflected wave. They'll undergo superposition, we'll get in a standing wave. So there's a conductor between two conducting walls. So we'll get an EM wave. There's an incident EM wave, there's a reflected wave. Then again, if you take this as a conducting surface, if you send an EM wave, suppose say how do we take this EM wave? So usually we do represent by what, like E bar and B bar vector. So if this is E bar, polarized thing is what I'm discussing. Oh, here. B bar, I'll put out of the plane. After reflection, we get like this, no? So there's the incident wave. After reflection, okay, there's an incident EM wave. There's a reflected EM wave. Then a part of wave will get reflected. So what will happen to the reflected wave? This is B bar. So there's a refracted and if you look at the energy, this E bar vector should be slightly less, no? A part of energy will be reflected, a part will be refracted here. So there's a boundary. The same like what all we studied, no, that you can apply for EM wave here. So you have to show that E bar and B bar, and they'll be always perpendicular. There's a direction of propagation. V1 you call it, first medium, in this medium, V2. This is standing waves. They will give some the expression for incident wave so that this will be node, 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 node. So any of the things can be asked here. So you have to pick the moment I say wave, so bring all the ideas of the waves. When I say reflection, refraction, bring all the ideas of optics, they can mix up for you. So they may ask you analyze for EM wave. There's a way what you're supposed to do here. Now you're getting no. So here I'll just ask you some generalized thing. If I give EX, then is it possible EX BY? Then in what direction the wave is propagating? Wave is propagating along Z axis. Agreed? If I similarly write like this, EY BX, shall I say wave is propagating along Z axis? I'll give components, this one. So third one. With this, what you can say? The wave is propagating along Y axis. Able to analyze this one? Always the E bar vector and B bar vector should be directed perpendicular. I'm talking about this a polarized EM wave. Unpolarized, what means the E bar, B bar vector will be rotating in a plane perpendicular to direction of propagation, and both will be mutually perpendicular. For polarized waves, the E bar will be confined to one plane and B bar will be confined to another plane. We'll discuss in detail in polarization. Time being, you can have this much of idea. So for unpolarized wave, what is the, I think somewhere here, I'll go back to this. Let me, E bar, B bar will rotate in a y-z plane and they propagate along x-axis and vary with time. Or what does it mean? The E bar and B bar will be mutually perpendicular. I'll add up that sentence, one more, that one. Vary with the time. Okay, fine. It should be like this. So they may ask you very good questions just only to, is it unpolarized or polarized EM wave? I think that you have to identify. Okay, I think we were somewhere here, no? So can you identify if they give like this? So last one more, propagating along Z. Already x-axis we have seen, no? So like this, the possibility. So it's not possible that, is it possible? Not possible, no? How E bar and B bar will be along same direction? E bar and B bar must be that one.
The second and fourth are same.
Okay, that one. EY, BZ, huh? It should be BZ. Yeah. This is not possible, no? Like this should not happen. No.
It should be EZBX. Fourth one, EZBX.
EZ and BX, huh? Yeah, okay, yeah, fine. And now your task question, sir. Is it always that E bar and B bar vector will be along certain axis only? Can't be they like this? Blue, we use this one, no? They're perpendicular. I have to show that they're perpendicular. First condition. E bar vector. B bar vector. How the wave is propagating, not along Z axis, no? At least I'm sure. So the wave will be somewhere propagating in this direction. So this will be the direction of propagation of wave. E bar is not along Y axis. B bar is not along Z axis. E bar lies in XY plane. B bar lies in, we should not say YZ plane. E bar lies in XY plane and B bar lies in minus X plus Y plane. Or this will be more confusion diagram, 3D. I'll make it just a plane. I think that will be sufficient. It can happen like this also. No. Of course, it is propagating along now, which axis? Along Z axis. But E bar and B bar, they're not along the axis. It can happen. I can orient the B bar like this. So all possibilities are there. Or you can propagate in a space. Here we are confined, it is propagating along Z axis. Wave is, okay, now how to show that wave propagating along in a plane, what happened? We go for a general representation like this here. K vector. This K vector is called a propagation vector. Wave vector, or also called as propagation vector. Very important. If a wave propagates along x-axis, k dot x bar, how much it will become? Only kx. If a wave propagates in a space, then this propagation vector will become very useful for us. So how to express that? It will be like this: kx. Again, it will have kx, ky, kz value that should be defined. Okay, now see, is it propagating along x-axis? No. You look at the k bar. So the equation will become very simple when it is propagating along x-axis. Then these two will not exist here. Will not exist. Then k dot x, k bar and x bar will be in same direction. So it will become simple equation kx minus omega t. This is in exponential form, complex number what we have. This is sinusoidal one. So x y of zt. So no, I think you must realize this. E bar. Don't try this. Then okay, this one. And how this E bar will be directed along y-axis or z-axis? It all depends upon that condition. They may ask you any question. Just be alert. I'll update few questions on this one. Okay, now after this, what is the expression for intensity of wave in different medium? So a slight discussion will make it. It's there for syllabus, I'm not sure. Let's have some basic idea, then we'll see. I think just only we know some little bit about electrostatics, other things, first year. If the wave propagates in a free space, EM wave in different mediums. The first one, free space. For free space, what will happen? Conductivity will be 0. Epsilon will become epsilon naught, and mu will become mu naught. Then what is the expression for intensity? Intensity will become is that okay? So this, in terms of ERMS, if you want to bring, you can bring, or F naught E naught square by 2. I brought this particular thing. F C will be there, no? Wait. Or you can express also in terms of magnetic field. This should be equal to C B naught square by 2 mu naught. This is in free space. Then what is the expression for speed? Speed will be 1 by root of mu naught epsilon naught. In free space, what is the speed of the wave? Equal to speed of light. Next again. In a lossless dielectric, conductivity will be 0. Epsilon will become epsilon r, epsilon naught, and mu will become mu r, mu epsilon naught. And we'll put a condition as it is lossless. Omega into sigma will be very much less than this particular thing. What about the intensity? Expression will be, it will become epsilon naught, epsilon r, C E naught square by 2. This is again like a lossless dielectric. Again, the dielectric, there are two types of that. Transparent dielectric, example glass. What is the mu r for glass? Will be 1. It all depends upon, again, the lossless dielectric, the conditions are there. Suppose if a ray of light propagating through a glass, what is the mu r for glass? Will be 1. whereas epsilon r will be different. The speed of the wave will be different. Since we bother more about intensity electric field, no, I'll just focus only on electric field, because the B bar, B naught is a quantity which we cannot, we can measure, but will a very costly thing. Equipments, costly equipment, size, everything matters. So that's why the books, they focus more on intensity in terms of electric field only. Now, what is the expression for speed? I'll put a special condition. Okay, here I wrote mu r, let mu r equal to 1 for glass. So what is the speed of the wave will become? V equal to C by yesterday's class, I think we derived these things, no? Expression for speed of the wave in any medium is given by this particular formula. For a glass, you have to use this particular formula. Any medium, what is refractive, what is the relative permittivity of that particular glass medium, that you have to substitute. We brought in terms of refractive index. Don't get confused with refractive index here. So therefore, what is refractive index now? The root of this should be the refractive index. Mu, again, don't get confused. It's not a refractive index. It's a relative permeability of medium. For a glass, since it is equal to 1, we substitute here. Lossy dielectric. Means where some conductivity will be there. Lossy dielectric means what, when, where if a wave propagates through it, some energy will be absorbed by the medium. So then expression for speed of the wave will be mu r epsilon r, then expression for intensity, the same thing. Then as the wave propagates, energy will be, energy of EM wave decreases. Lossy dielectric, as wave propagates, energy of EM wave decreases as medium absorbs energy. We let's not go in detail. It's a very what you say, dynamics of EM wave. It is like a electromagnetic dynamic what you can say, like a electromagnetism, that one, dynamic electromagnetism. What all we study is a static one. So these are very, I think we have to put lot of mathematics. Everything will come in vectors. So that's why everything we are just confining ourselves to just formula based here. Okay, this is, I think, third one. Now, what about the conductors? Conductors, what happens? The sigma will be infinity. The relative permittivity will be 1. And mu equal to mu naught, mu r. Here, sigma will be very much greater than, with respect to EM wave, here discuss, not with respect to electric field. Again, don't get confused. I know that in, we put infinity, no? Epsilon r. So with respect to EM wave, we are analyzing it. Dynamic electric fields, varying electric fields we are discussing, not static electric fields. So don't get tempted to write here infinity. Here. So what will happen to the EM wave? Can it propagate in a conducting medium? Yes, it will propagate here. Conductivity will be very high, or say infinity. And the speed of the EM wave, in terms of this, we can write it as V equal to C. Mu r will come into picture there. So the magnetic property matters a lot. Sigma will be very much greater than this quantity. Or so EM wave, what will happen? Can it pass through a conducting medium? Next, another condition will come, that one. And what is the mu r for conductors? Very high, no? So what is the speed of EM wave? Will be very less. So that's why. So if you take the EM wave, what happen? You want to block it. Yes, you can take help of the conductors. Any, I think just confined to formulas, not discussed in NCERT or SC Verma book. I just give some additional information. I myself don't know whether they are there for syllabus or not. I'm not very sure. Just some additional information, you can take it.